Hello, everyone, and welcome to our Thales Press webinar. This afternoon's webinar, Engineering as a Career Field, is presented to you by Mr. Bill Griffin and hosted by Thales Press. I want to thank everyone for attending and for Mr. Griffin for preparing this talk for us. I also want to take a few moments to introduce myself and explain what Thales Press is all about. For anyone who doesn't know me, my name is Winston Brady, and I'm the Dean of Academics at Thales Academy. I've been teaching at Thales for 11 years now, and for the past 5 or 6 years, I've been helping to create curriculum for use in our program. These educational resources have included textbooks, seminar readings, and videos that support the unique brand of classical education that we provide at Thales, from our K-12 program to our newest venture, Thales College. To help promote the values and virtues of classical education, Thales is establishing an in-house publishing firm known as Thales Press. And the goal of Thales Press is simple: to enlighten minds and empower students through the contemplation of what is good, what is beautiful, and what is true. With all that being said, now it's time for me to turn it over to Alexandra Stroud, our development coordinator, for details concerning tonight's webinar, and then to Mr. Griffin, our special guests.
Hello, everyone. I will remain a talking head for right now, but thank you again for joining. I just want to give you a little bit of protocol for how we're going to do our Q&A at the end of our presentation. As questions arise during the webinar, please write them down and save any that you might have until we get closer to the end of the presentation, which will be marked by the final thought slide, and then send them into the chat box. And we do this just in case our speaker ends up answering your question along the way and you don't necessarily need it answered again. We will have a brief Q&A at the end of the webinar, and although we may not get to all of the questions, if you do add your name and email address at the end of your submission, if it was not read, we will be sure to follow up with an answer in the email. All of our webinars will be placed on our Thales Press page, which can be found through our Thales Academy resources page and on YouTube. So if you would like to revisit our conversation from tonight or to share it with your friends, we will let you know when the video is posted via an email, or you can look it up on YouTube and find it there through Thales Press. And please feel free to contact Winston with any other questions about this series. His email address will be posted at the end of the presentation. So with no further ado, I would like to invite Mr. Griffin. Thank you for joining us.
Thank you, Winston and Alexandra. It's my pleasure to be here. And, I was happy to be invited to this to go over some of the observations and things I've learned over my engineering career. And again, my name is Bill Griffin. I'm a graduate of the University of Maryland. I graduated in 1998, and I'm fortunate to have worked for one company my entire engineering career. That's Captive Air, and it's been very challenging and rewarding. So just to get started, just as a little bit of a background on engineering as a career field, there's many types of engineering disciplines out there. Most people are familiar with the mechanical and electrical fields of engineering, but there's a large array of engineers, including industrial, sales. There's chemical engineers. There's a lot in biology now. There's a lot of growing fields. And one thing that's true in all industries that we're aware of is there's a need for strong engineering talent to advance technology and to advance those companies. We're seeing it right now within our company that we're somewhat limited based on the amount of engineering talent that we can hire to move things forward. So there's a huge market for good engineering and well-rounded engineers. There's many opportunities in almost all geographic locations. That's a really large benefit for your career. If you're considering moving or want to move around the country or different areas of the world, the good news is engineering practices are the same no matter where you're located. So it gives you some opportunities in your career to move around. Engineering can be both challenging and rewarding. There are many, many days that are very challenging as an engineer. And that's sometimes can be viewed as very hard, but those opportunities and those instances allow you to grow as an engineer and grow as a person overall. And when you get through those challenges, you do have that sense of accomplishment and reward. So view it as an opportunity, not as a negative thing. What one constant is, there's a constant pursuit for improvement and knowledge. That's one big thing that you get out of an engineering career field, and one big thing that you must put effort into achieving. There's no end to the amount of challenges to solve. And, someone asked me one time, don't you ever feel that you must never feel a sense of closure because your job never ends. You're always going from one challenge to the next. And that may seem true on the outside, but you have to break challenges down into individual goals. And once you reach those goals, there is a sense of achievement, and you keep going, keep progressing to the next goal. It is never ending, but it's very satisfying as well. So why choose engineering? Why choose this field to make it your career? My observation is there's usually an underlying curiosity of how things work and how things can be improved. There's one saying that with engineers, if it isn't broken, take it apart and fix it anyway. So that's one thing that a lot of engineers have a curiosity about, how things work and how can they be improved. You have a desire to improve products, process, public health and safety. Whenever most engineers will look around and see and observe, how can I fix things? And this can be a little bit of a pro and a con, because sometimes people and groups want you to just listen. But I've noticed that some engineers, including myself a lot, hear a challenge and immediately we start thinking, how can I fix that problem? So that's a general trait of engineering, just being a problem solver. One very rewarding thing is your decisions and choices can have an impact, a very tangible impact on what you work on. One of the most rewarding things I did as a young engineer working for the company here is, after I designed my first product and witnessed it rolling down an assembly line, I was really blown away. I was amazed that I could turn something from a three-dimensional solid model into a product that makes money for the company and is profitable for the company. So when you see that come to life, it's an amazing feeling. The next thing is Kaizen. Kaizen is a principle that that states you are in constant mode of improvement. And this improvement comes with the very little changes. It comes with a lot of little changes over a long period of time. And at the end of your career or end of a project, those little changes add up to make a large impact. It's been our observation that large instantaneous changes are very rare, and most growth and most improvement comes from this practice of Kaizen, where you get better each and every day. You also must be passionate about what you're learning and what you're working on. If you're not passionate about what you're doing, you're probably in the wrong career field overall. So whatever you do, whether it's engineering or something else, be passionate about it, and that will pay dividends. And the other thing to consider about why you choose engineering is just a basic economic one. And you want to review different degrees and colleges. And for example, Thales offers a very strong educational background that will set you up for the rest of your career. And it comes at a very reasonable cost. So one thing I would discourage is choosing it to be an engineer and then going to a very prestigious school where you rack up a lot of debt and have to pay for that year after year after year, long into your career. So make sure when you're reviewing options to take that into consideration. Engineering can be since it's high demand, it can produce a very good ROI on your education. Next thing is decision making, and this is a very challenging thing that we deal with every single day. during interviews of new or potential employees, I asked this question, what makes a good decision? And the candidates' responses are usually all over the board, but it gives me a way to kind of look inside of their mind to see how they process information and process their own decision making. I can tell you from personal experience, we make decisions all the time with very little or very limited information. And that isn't because we don't have access to information. It's just because we don't always have the full picture when we have to make decisions. So you have to be alert, be aware of all the consequences of your decision making. But just keep in mind that in the real world, you will not have all the variables fully defined for you. And you have to make decisions with the amount of information that you have. So in order to do this, you have to trust the physical laws and theory. And I would say one of the biggest things that you get out of your engineering degree is you get a strong basis in that theory. You must also use common sense and be alert and aware of the things around you. So one other thing, safety and quality must never be compromised, and especially safety. These are factors that must go into every one of your decisions, whether it's a process or product. Think about safety and everything that you do. Do not design on the margins. So what this means is you'll hear a lot in your engineer career about safety factors and redundancy. You never want to design with a 1.0 safety factor. So it's impossible to predict all the variables that products will be exposed to. No matter how long you do something, there's always things out there that will surprise you. So you have to design and work your projects with some sort of redundancy. And what I mean by redundancy is, say you have a critical system. If part of that critical system goes down, you don't want to take the entire system down with it. You want to have a redundant plan, a backup plan, and everything that you do to make sure that systems and operations continue to function if things go wrong. And trust me, things will go wrong. You just have to have a plan for when they do go wrong. Time, economics, and long-term sustainability must all be factored in. This is critically important today's day and time. Sustainability, we want products and process to be long-term. We want products to be long-lasting. This is one of the biggest things that we can do to make good decisions and make things last as long as possible. The last item here is have a day one mentality. And this was a phrase coined by Jeff Bezos, the founder of Amazon. And what he meant was when you start a new class or with a company, day one is very exciting. You're learning, you have new ideas, you're very energetic about things. And that's where a lot of progress is made. As time goes on, it's harder and harder to have that day one mentality every single day. So try to focus on that day one. And what would you do if you were living and working that day one every single day of your schooling and your career? The other thing is practice the founder's mentality. And that's sometimes hard to do because the founder of a company has made the company successful by the way they think and act. So when you work for a company or when you're in a school setting, think about what the professor's trying to teach you. Think about what the owner of the company is trying to achieve, and put yourself in their shoes and try to make the decisions like they would make decisions. It's sometimes hard to do, but when you put yourself in their shoes, it kind of brings clarity to some of your decision making. Looking at the economic side, and when I'm talking about economics here, it's not necessarily just the the value of money over time. These are economics that go into engineering challenges. So, if most engineers are given enough time and finances or money, we can solve major challenges. A few years ago, I studied for my professional engineering exam, and the professor told us, most engineers can solve any problem if you give them enough time. The problem is with this exam, you don't have unlimited time. You have a very finite amount of time to solve these challenges. So you have to change your way of thinking when you work in a profession where it's fast paced and you must keep progressing. We do not have unlimited time and resources. As a matter of fact, time is of the essence in mostly everything we do. So keep that in mind. Time is very valuable. And I will promise you this, the later you go in your career, the more valuable time becomes. So we have to make wise decisions, but we also have to make them as quickly as we can and move forward with those decisions as quickly as possible. When you're looking at materials, in today's economy and market, there's a lot of different material selections. Material sciences have come a long ways, especially over the last 2 or 3 decades. So material selections are very critical. Labor requirements are true cost. Labor is very challenging right now. It must be factored into your design. So we look how can we automate things? How can we design things for manufacturing to reduce the amount of labor input needed into products and designs? And lastly, quality. When you try to put a price on quality, it's oftentimes priceless. And what I mean to say is, it's very hard to gain good quality and a good reputation as a company and as an engineer. It's very easy to lose this. You can lose this almost overnight, and it can come at you from different directions. It can come from a component selection that you may have made a year ago. It can come from a process that's just going wrong. External factors out of your direct control, but quality is it's a long-term way of thinking. And again, it's very hard to gain it, but very easy to lose. So keep that in mind in everything that you do. All right, there's always a need for more engineers. From what I've witnessed, the best engineers, they have a good balance between theoretical knowledge, practicality, and knowing how to apply themselves. So a lot of engineers may come out of school with a very strong theory, but don't know how to progress and don't know how to actually apply themselves. And this comes from a well-rounded education and a well-rounded personality, you could say, to make sure you're interacting with others and moving things forward. As time advances, the products and the processes we work with become exponentially complex. So new engineers are important to this process because new and younger engineers have talents in areas that more experienced engineers may not. So, for example, social media or using new digital tools that are new now that didn't exist when older engineers were in school or learning the process. So there's always a need for that steady flow of new engineering talent to support those technologies. Also, engineers, as well as everyone else, they want to advance within companies and they want to advance in their careers. They want more responsibility and to move up. So there's always a constant need to backfill those entry-level engineers, so there can be a wide array of experiences within a company and organization. And I can tell you also, just within the immediate research and development group at Captive Air, there's a good mix of engineering talent. We have engineers that are very good with theory, very good hands-on engineers, and it takes a mixture of both to make things work. And I will say the best engineers have a blend of all those traits. They know how to blend those traits together and act upon their theory and their practicality and move things forward. All right, some pitfalls of engineering degrees. This is something I was thinking about, and what will separate different colleges, and just give students something to think about when they're trying to make the decisions there. A lot of engineering graduates come out of school and they think they know absolutely everything. This is absolutely false. The true learning experience, in our opinion, starts with the first day on the job. Now, there's good theory that's learned in colleges and universities, but there's a different way of engineering and a different practice of engineering once you're on the job. So the first day of a job is where your real learning experience starts. I witnessed this myself going to the University of Maryland. There were very large lecture halls, and sometimes we had 300-400 people in a class. And you could just look around and you could identify the people that weren't paying attention. They were going to get lost in the numbers. So these large universities, they have their upside. They also have a downside where you can get lost and you can fall through the cracks and not be successful because it's so large. Don't be a cut and paste engineer. I knew a lot of students like this. They would try to apply one answer to multiple different problems. And that can continue with your career. There's not a one size fits all solution to every problem in the world. And a lot of times things get overlooked when you try to do that. So don't be what we call cut and paste engineers, and learn from your mistakes. It's important not to repeat them, but it's okay to make mistakes. This one mistake that's it's somewhat well documented. Ken Iverson, the president of Nucor Steel, had a business manager that purchased a melting process for steel for $10 million. And that melting equipment failed. It was not successful. Being Ken and the gracious person he was, he didn't hold that person ultimately responsible for that mistake. They learned from that mistake and they moved on. They didn't repeat it. He was very gracious in that regard, but the idea is here, you're going to make mistakes. They're not all going to be $10 million mistakes, but it's okay to make them. We just shouldn't repeat them. All right, real world engineering. So there's challenges that come up each and every day that aren't about formulas and they aren't about equations. Some of those are supply chain issues, part substitutions, tolerances. We have to make decisions each and every day on things that are somewhat outside of the normal engineering role. With today's supply chain issues, for example, we spend a large amount of resources redesigning and reevaluating products to work in our main assemblies to keep things moving. So they're not all design and they're not all true like theoretical engineering. There's a lot of engineering talent required to make these other decisions. Team dynamics are very important. The bigger the teams are, the harder this becomes, but there are a lot of different opinions on how to achieve end goals. You have to be willing to work with people. You have to be willing to hear their ideas and make it a conscious effort to actually listen to people. And their ideas may not be the best, but it may spark other ideas for you, and ultimately makes things better to get everyone's opinion, then move on with the best decision. Public speaking is a challenge for most engineers, including myself. I'm not the most comfortable at it, but I try to do it. I will say it's critical to make this work, because you can have very good ideas. You can be a very well-rounded engineer from a theoretical standpoint, but if you can't communicate your ideas and your your concepts, then they'll never come to reality. So it's important to be able to get your point across in a way that everyone can understand. And just to reiterate, learn how to deal with challenges and adversity. There will be bumps in the road. Not every one of your ideas will be accepted. Not every one of your ideas will be as good as you think they are. So learn to deal with those challenges. Move on quickly. Don't hold them. Don't take them personally. And you'll be fine. Just keep moving forward and have perseverance. Some things are not solvable in a day, an hour, a day, even a year. There's been things that we've worked on for many, many years until we've got them completely correct. So it's important to have perseverance, to stay on problems until they're solved. And I know I mentioned that we don't have unlimited time and resources. There are priorities. You have to prioritize your work, but you can always be thinking about these things in the background, in the back of your mind. And at some point in time, it's going to be clear enough to solve. So just don't give up on things. All right, so for you students that are listening today, I'm going to encourage you in these areas. One is learn as much as possible. And what I mean by that is, from a theoretical standpoint, work as many problems as you can. And as a student, you may feel that homework or problem solving is a burden, but trust me, the more problems you work and the more problems that you're experienced with, you're going to be a more well-rounded engineer. Don't be afraid to ask questions. There's more than likely, there's multiple people sitting right beside you that have the same question that you do. So don't be afraid to speak up, ask those questions. I can tell you, when I first started the job at Captive Air, I probably asked my immediate boss way too many questions, and I thought he was annoyed at me for asking so many questions, but it paid off in the long run because that was part of the learning experience. Interact and study with others. Sometimes people, your coworkers, fellow students, come at problems at different angles and come at solutions differently than you would. So I remember when I was in school, one of my good friends there, we studied together a lot, and he would come at just about every problem with a different angle. And I learned a lot from him, and he learned a lot from me. And the good news is we still stay in contact with each other nearly 20 years later. So you can make some long-term friendships by interacting and studying with others. One of the most important things is gain a strong theoretical background to prepare for future decision-making. That's one of the biggest things you can come out of school with, is a strong theoretical engineering background. Also, be as well-rounded as possible. Dailies will prepare you for that more than any other type of school setting, in my opinion. Understand that life isn't a formula. Life isn't always fair sometimes. It can be complicated, but try to be as well-rounded as possible, get along with everyone, and studying is very important and get that theoretical background. Some final thoughts. I like this quote by Henry Palmer. Henry was a British engineer responsible for some of the rail systems in England. And he said, the engineer is a mediator between the philosopher and the working mechanic. And like an interpreter between two foreigners, must understand the language of both. Hence the absolute necessity of possessing both practical and theoretical knowledge. We see this in reality. We just released a major product a couple years ago. And there were theorists that had been thinking about this product for decades. And then there was an engineer that was responsible for mainstreaming the product. And then we brought it into reality as a company. So this process can take a long time, but the engineer must be able to talk in the theory and in the practical sense of actually working with production workers on how to build things properly, So we have to be an interpreter sometimes. So some final leaving thoughts here. Just remain curious about everything. Curiosity is a very important trait. Learn how to interact with others. This will be a big part of any job that you have. And I like this last one. Good ideas are just good ideas unless they're acted on. You have to have the gumption and the attitude that you're going to act on these ideas. And you have to have a good balance between those two.
Mr. Griffin, thank you so much. That talk was fascinating from start to finish, and I really enjoyed hearing about your experience as an engineer. We have an opportunity. We've got some time for questions. So for anyone that you have a question, something came up during the webinar, you can go ahead and type it into the chat box now, and then we'll read it out to you, Mr. Griffin. While people are getting their questions together, I did have one question. Going back to that idea of Kaizen and that state of continuous improvement, my favorite Kaizen story is behind the Toyota Sienna minivan, which some of the viewers here might have actually a Toyota Sienna minivan. When they were redesigning that minivan, the engineer in charge of that project actually drove around the United States, Mexico, and Canada in a 13,000-mile road trip to figure out all the ways that he could improve the Toyota Sienna minivan and just make it as easy and accessible as possible for families, look like the people who are actually using it. That was a pretty huge improvement, but I was wondering if you have a similar success story with Kaizen, maybe not quite as long as a 13,000-mile road trip, but perhaps something that really exemplifies those small changes that add up to absolutely phenomenal results.
Yeah, I will say, personally, I pick up some products, and I do, I'm a fairly hands-on engineer. So I'll work on some products and I'll be like, what engineer designed this product? Because this bolt's in the way of this bracket or whatever. So I can fully understand the benefit of being hands-on and being directly related to the product that you're designing and actually using it. I guess an example of Kaizen with what we work on is, we have a product called Paragon. It's a dedicated outdoor air system, RTU, and we've been working on this since about 2013. So we started with a initial prototype, and over the course of about 5 or 6 years, we kept improving based on feedback and actually our engineers using it. And now it's a very mainstream product and a very desirable product from the industry. So just that constant progression and constant improvement over years has made a big difference in that product. And it's a very successful product because we didn't give up on it. We kept improving on it.
Well, Alex, are we ready to start reading out some questions for Mr. Griffin?
We don't have any yet, so you can keep asking.
We're still waiting on a few questions. Well, Mr. Griffin, did you take things apart as a kid? And then a follow-up question, could you put them back together again? Because I certainly took some things apart, but rarely could I ever put them back together so that they would actually work. I mean, how early did your passion for engineering start?
I remember the first thing that I took apart was a little radio. My parents tell me about this all the time. I took it apart and it was about 100 pieces. It didn't go back together after I was done with it. So I was under 10 years old at the time. But I've always had a curiosity on how things work. Just today, for example, we had a potential vendor in, and we were taking apart an existing product that we have to show them how it works. So that curiosity never ends. And we love, when vendors or suppliers come in and visit our R&D center here, we love teaching them how things work. And one way we do that is to dismantle products, show them the inner workings of it, it's a fun experience.
Thank you, Bill. So we have a few questions that have come in, and I'm just going to go ahead and ask them to you. The first question we received was, why did you want to become an engineer?
That's a good question. I was when I applied for engineering school, I didn't view any other degree as a possibility for me. I just had my mind set. That's what I was going to do. So I explored briefly other degrees, but in my this is the only one that made sense. Just knowing the way my mind works, and I was fairly good with numbers and good with my hands. This seemed to fit my characteristics well.
Okay. The next one is, what's the best way to see what an engineer career is really like if you are a high school student wondering what a typical day might be like? It's hard to imagine what an engineer does all day if you've never been one yourself.
Yeah, that's a very good question. That's going to be different in every different engineering field that you would witness, whether you're working on chemicals or machine design. So one of the better ways to do it would, would be actually to tag along with someone, if you had that opportunity on a daily basis, to witness what they work on every day. There may be, there's the nice thing about our job here is we work on different things every single day. So some days we may be working to build a prototype. Other days we may be actually on a job site helping with a problem. We may be in one of our production plants working on improving a process or introducing a new product into the plant. We may be working in a 3D design, solid modeling. So I guess the answer is, if you had the opportunity to tag along with someone for a day or two, that'd be a very good experience. But it's going to be a broad range. I do encourage you to work with a company that you get to see a lot of different experiences and not get laser focused on one specific thing. So the more that you can be exposed to, the more well-rounded you'll be as an engineer.
Awesome. What are the most helpful subjects for a student interested in engineering to take in high school and in college?
Okay, in high school, I really think a strong background in physics in high school will prepare you for engineering. Physics and engineering are very closely related, actually. There's different long-term goals, but the educational process is very similar. So you have a strong, if you have the opportunity to take physics and even AP physics or advanced placement physics in high school, that would be good preparation. I'm sorry, what was the second question, Alex?
Well, it was high school and then college.
Oh, college. Okay. So college, it depends on your discipline. But I can speak from a mechanical standpoint. There are a few classes that are very critical. Machine design, mechanics of materials, fluids, thermodynamics. Those are very critical. Fluids is one of the most challenging classes that I took, but it had the most relevance to a lot of things that we do. I also, when you're at your senior level and can sometimes decide where you want to focus a little bit, pick something that interests you. For example, I picked an HVAC design class as a senior level class in college. And that was one of those beneficial classes that I took. It prepared me well for what we do on a daily basis here.
Neat. I didn't know they had those. What are the best and worst parts of your job?
I would say the best part is being able to be exposed to so many different challenges, and working with a lot of different people, it really stretches your thinking process. You know, you become, even after 20 some years, there's always things that surprise me every single day. So you're always learning about something new. One of the hardest parts of the job is, for me, is separating from it. I like to be totally engrossed in what I do. So it's hard for me to actually turn my engineering mind off sometimes and not think about what I need to do or the challenges that we have. So that's what I'd say is the hardest thing, or the maybe the most challenging thing about my job.
The confessions of working in a field you love, I guess. The questions are rolling in now, so this is great. How has technology changed your field, and what fundamentals have stayed constant despite technology?
Okay. I would say that the most growth or the most dynamic part of what we do is in the electronics world. So electronics and the Internet of Things, for example, communications have advanced at a faster pace in the last 5 to 10 years than the previous 10 years. So that's changing every single day. It's actually a hard thing to keep grasp exactly where we need to go with that because it's changing so rapidly. Some things that have remained constant are, your physical laws. Like for example, we use something called the psychrometric chart in HVAC every single day in things we do. And we use equations and formulas that apply to that chart. That has not changed at all from the time that I learned it in college till now. So your basic physical laws and theory will not change over time, but the industry around you will change, and the market demands will change. So one of those, like I said, one of the fastest paced changes has been in electronics.
What are your thoughts about college students working as an engineering intern while they're attending school?
I think that's very important. We encourage that here. I think that it opens your eyes, especially in the latter part of your schooling, on how to think about problems a little bit differently. You get a jump. You also get a jump start on your career once you graduate. So that's critically important, in my opinion.
Thanks. Bill, have you ever had an idea or process you were directly working on that failed or was rejected? And if so, how did you handle that?
Yes, I've probably had many. As a matter of fact, I've developed products at the company, and we've already obsoleted those products over the course of 20 years. So you take pride in what you do, but you can't become too close to those things because things are going to change. And you have to realize things change, and you have to keep growing. So yes, I've had ideas that have been not good and they've never gone anywhere. That's going to happen. And just be willing to adapt and embrace, I would say embrace new employees, because they bring a different perspective at things, and they'll help you with your thinking as well.
Okay, our next question. Do you see an employment gap of females in engineering? What specific engineering fields have the largest gap in your opinion?
That's a good question. I know when I was in college, there was a large gap. I remember in some of my large classes, if there were 100 people in the class, there would be 5 females. So I do think that gap is closing some. And I will say that there are traits that females bring to engineering that are very important. So for example, I think that sometimes females can they can maintain a higher standard on things that cannot be negotiated. That's a very important thing to maintain. So I do see the need for that and a need for more females. And I do think the gap is closing, which is very important.
Are there any particular fields you think that there are definitely less women than in others?
That's a good question. I'm not really sure how to answer that. I will say the HVAC world that we live in, it's pretty heavily biased towards males. If you go to any of the society events or any of the trade shows, it's pretty heavily biased towards males. So chemical engineering, I would say, had a larger percentage of females when I was in school. So I can't answer it more precisely than that. Sorry.
That's okay. I wonder partly how much of that is interest-based as well.
Yeah.
But okay. What has kept you with Captive Air over the years versus exploring a different company?
I would say there's been the ability to grow within the company. And for anyone who knows Bob Luddy, he will challenge you every single day. So the challenges, you have to be challenged and you have to have goals. So at Captive Air, we have 100 different challenges every single day. And there's always new challenges. So we don't have a chance to get tired of what we're doing. The new challenges basically will keep you interested in your career and keep you moving.
Great. How might you decide which type of engineering to major in? There are so many options.
Yeah, I think you'll have a tendency to latch onto the areas that you're interested in. For example, we have electrical engineers here. We've hired aerospace engineers, mechanical, industrial engineers. So it depends on actually what your interest is in. I will say the electrical engineering field is very applicable to today. It's very tough to find strong electrical engineers. So I would encourage more to try that direction, but you'll have an interest. You just have to ask yourself, what are you interested in? And that'll help you decide.
Yeah, and just expand off of that. Okay. Statistics and probability is key as well statistics and probability is key as well from another CAS engineer. So I guess he was referring to, I'm not sure.
Maybe the good classes to take in college.
Yeah, statistics. Oh, and probability.
Taking all that data.
Yeah, as a CAS engineer. Yeah, thank you. That came from one of our really great CAS engineers. Thank you for adding that in. Our next question: what field is the hardest to work in?
For me personally, the chemical engineering and the electrical engineering are the most challenging. There's a lot to know there. There's a lot of new technology, especially in electrical, with new technology available. So I'd say that's probably the most challenging right now.
All right. What factors do you consider most important when selecting an engineering college?
My first thought is economics. I wouldn't want to have to pay for my college for many years after graduating. If you graduate and you come out with a lot of debt, that's going to restrict you moving forward in life a little bit. So that's probably the largest factor. Also look at how colleges rank. The ranking process can be a little indicative of how well the engineering is taught there. I'll say this though, no matter where you decide to go, the effort that you put into it is going to be reflected on what you get out of it. So if you go through engineering school and you barely put any effort into it, you're going to get a barely an engineering degree. So if you put a lot of effort into it and dig in and try to learn, you'll be successful generally wherever you go. But you have to put your effort in.
I couldn't agree more. All right, this is our last question, and we have time for a few more. So if there's anybody who's really got something that they are kind of wondering about, go ahead and put it in the question field. This one says, do you believe an engineering degree is required to be an engineer?
I do not. There are many self-taught engineers that are very, very competent. As a matter of fact, we used to work with a self-taught engineer. He taught himself everything there was to know about circuit board design. And he was probably the best circuit board designer that we've ever worked with, period, hands down. So he did not have a degree in electrical engineering, didn't have a degree in circuit board design. So to answer your question, no, I don't think the engineering degree is critical to be an engineer, especially in today's day and age where anyone can look up anything on Google and try to figure things out. So I will say that the one thing the engineering degree does prepare you for, it forces you to stay disciplined and learn that theory, which some people may not be able to do that on their own. You may not have the discipline to devote the time to learn that theory on your own. So the college experience for engineering, learning that theory, that's the most valuable thing you're going to get out of it.
Thanks. I think that's it. I do have a question. I think you pointed out in your presentation that public speaking is essential. And I know that I've spoken with several of our employees actually in regards to public speaking. And these are bona fide engineers who are also that's still something that they realize, like that kind of soft skills, people skills is not something that normally comes to them naturally. And I've praised you several times for how well you speak in front of people, even though I know that's probably not your kind of comfort place. Can you kind of give some tips to other engineering minded people, maybe even personality people, on how to really just get themselves out there and practice speaking?
Yeah, like with anything, mostly anything in life, practice makes you better at something. Whatever you do, keep practicing it. I will also say I missed one thing about important classes to take. Technical writing in engineering is very important. It helps you organize your thoughts. It teaches you how to organize your thoughts, and it actually helps you with that public speaking side of it as well, because the more you know a subject, the better you're going to be able to talk about it. When some of my engineers present at meetings or do any public speaking at all, I always remind them that they know more about what they're talking about than the people listening. And that hopefully gives them some comfort in being able to talk about it a little more fluently. So technical writing, understanding how to organize your thoughts, and just practice. And, look at, observe some of the better public speakers out there. We have our own Bob Luddy is a very good public speaker. So just observe how they speak and their traits, and it'll make you better.
Thank you. And I will add to that in that I think learning how to recognize what you know and speaking off the cuff, like based off of what you know, I think it makes people a lot more comfortable around you, and it makes it a lot easier for people to kind of practice that as well. So I think both you and Bob do that well. But thank you so much, Bill. I think those are all our questions. I'm going to turn it over to Brady so that we can close this out.
Thank you.
Thank you, Bill, and thank you, Alex. This was such a great webinar. This is a really encouraging talk. The questions were fascinating, and just can't thank you enough for your time. We do have another webinar upcoming. So if you guys are interested in seeing how the sciences and the humanities can be integrated and work to advance each other. I mean, I was thinking, Bill, as you were referencing, getting better at public speaking. I mean, the first thing that came to my mind is reading Cicero, which is appropriate for our next webinar, which is Loving and Learning Latin with Dr. Will Bagley. He's a Latin and Trivium teacher at Thales Academy, Rolesville. Some of the people in this webinar here might be Thales Academy, Rolesville students. And so you might know Dr. Bagley already, but he's going to give us some of his tips for learning Latin and memorizing Latin paradigms, as well as just some of the value of learning Latin as a means of encouraging academic skills. So, Bill, you mentioned memorizing all those formulas, applying them quickly and on the job. Latin is a wonderful, as a humanities teacher, Latin is a wonderful means of encouraging those same skills there. At Thales Academy, we want to bring together the humanities and the sciences to prepare students for whatever challenges lay ahead. So for Thales Press, this is the conclusion of our webinar. And again, thank you everyone for attending. Bill, thank you so much for your time, and for everyone who's helped make this webinar possible.